This is our second in the series of the OMFIT tutorials. Last week, we talked a little bit about generally what OMFIT is. Today's is going to really get into the specifics of some tools that you can use immediately. Yeah, so we're going to talk about Scope, PubFig, and Database Creator, and it's going to be a really good tutorial. We have Quinn Pratt right here, who's a UCLA PhD student. He's a major contributor to OMFIT, and grateful for all the work that he's done. He really helps keep this OMFIT working. So just want to hand it over to him. Thank you.
Okay, thanks, Will. Okay, so actually, it's funny enough, I'm not really a big contributor to Scope specifically, but this is like, you know, a very important module, I'd say, to start out with. So that's why we're starting the tutorial series with this module. So I'm here and I'm in an OMFIT project, and I'm cheating a little bit because I already have imported Scope. In fact, I've imported it twice because I have different things I want to show in each one. So, you know, but if you didn't know how to do this, you go File, Import Module, and then you'll find Scope in the list and you can import it. So a few things I'm gonna touch on are going to be, there's 3 different workflows in Scope. So I'll open the Scope GUI by selecting it and clicking Enter. At the top, there's this dropdown that's Workflow. And there's 3 different options. There's the Scope Signal Viewer, PubFig, and Database. So I'm gonna start with this first one. And the basic idea of this version, like area of this Scope module, is kind of like a mini version of Review Plus, if you're familiar with that tool. So it's for looking at time histories of things going on in shots. And it has this GUI where you can enter a list of shot numbers, and then you can pick from this predefined device-dependent list of signals, and you can plot them. So I'll start with just removing everything, and we're starting very fresh here with just one shot number, and then we can pick our favorite point names, quantities here, and add them to this list. So let's pick the line average density, the EC core, and you know, the whatever we want, N2 RMS or something like that. Okay, and when I click refresh, you'll see that it added them to this list down here. So if you already know point names that you don't need to scroll through this list, like if you wanted to just add IP, for example, you can just add it as a string and hit enter. Whenever there's an entry box on OMFIT that's green, you have to hit enter to actually say, yes, accept this as a change. Otherwise, you'll be very confused. So from just doing this, I can hit plot, and there we go. It plotted some time histories from that discharge. It plotted them in the order of the list. So we have density, and then we have, I forgot what I put, EC core, N2 RMS, and then IP, like that. But you can change this layout. This is set up for, I told it to make multiple columns because maybe I was gonna have a lot of point names. But anyway, if you don't want to bother picking individual point names, you want to just say, look at something that is predefined, you can select, for example, overview. And if you click restore this group and go back to your signals list, you can see now there's quite a long list of different signals that are supposed to be sort of an overview of this discharge. So now I'll click plot on this. It's going to take slightly longer because it's a lot more signals, but still done in relatively quick time. Now we have, you know, all of these, and again, you look at the list to remember exactly which one they are. And they have their units. If the NPS value of each data thing stores its units with it, then they'll be here. Okay, so that's pretty simple. Let's say you don't like this super tall aspect ratio figure. You can go to advanced, and then number of columns, for example. So I could change that to 4. And you can change your time range, or you can select times that you want to mark, for example, with like vertical lines. And I'll replot this, and now we get maybe a better looking figure where these things are spread out a little bit more. So there we have that. And I should also mention my like axes are extra bold, and my font is really large because I changed the default plot style. This is a nice trick. So if you go to plot styles, and I reset to defaults, if you're following along, yours might look more like this. Pause for a sec. So here, you can see the axes are not as bold and the font is smaller, but I thought for a presentation, what I did is go plot styles, OMFIT, that. Don't worry about that, not relevant. Okay, great. So that's basically it for the scope signal viewer. Yeah, I'll take questions. What's up?
One feature in Review Plus is you can choose a particular window to blow up to take up the whole window.
Yes.
Is that
Actually, it is. It's part of Matplotlib. It's not even, I don't think it's even part of like that OMFIT had to program it in, but I don't have a mouse, but it's the third click. So like if you click, depress the wheel of your mouse on a given Matplotlib axis, it will make it the whole figure. But I'm on a trackpad, so I don't think I can actually do that. But I think technically if you like three finger, I don't know. Anyway, yes, you can do that. I should also mention that because this is Matplotlib and not IDL or whatever, down here I can already, like, there are tools already built into Matplotlib for zooming and panning, and there are actually additional things that are slightly hidden. So let me clear this set of things and make it much more simple. So for example, if I just added the density, whoops, I still told it I want 4 columns. So that's why the figure looks like that. So for example, you can configure this subplot. So you can change how this looks, and it's really scrunched because I told it I want so many subplots. So one sec. There we go. Okay, so if I have this, for example, there's all these little widgets which OMFIT did add. Like these aren't built into Matplotlib. So for example, adding this crosshairs, or if you click select and then you can right click on things. So let's say you don't like that color, you can change it to red. Or if it's too bold for you, you can go down to the line width, change that. You could make it even more bold if you want, or you could change the line style. So you can just edit this as much as you'd like.
Oh.
What if I want a final copy in my email?
Yes, if you want this, you can click the email button and it will, it's pre-filled with my info. Please don't spam me with emails, and then I can send this to myself. And usually in a minute or so, I'll get an email, put an asterisk on that. Sometimes the email functionality is slow on Iris, or I don't know, something's going on with it. It's not the end of the world. You can just hit save. And if you save it as a PDF, it'll stay nice and vectorized and all that. And then you can just put it anywhere you want and, move it to your local laptop, for example. Yeah, I think that's pretty much it in terms of manipulating individual figures. Yeah, go ahead, Wookie.
What if I want to plot density target on top of density so I can make that comparison?
Yeah, so, okay, if you want to overplot things, maybe now is a good time to switch to PubFig, which is for really fine tuning. Well, like, okay, I'm pretty sure. So, okay, if you're ever unsure, you can click these question mark, these context help buttons. And this tells you, for example, like what you can enter in this. And there's a whole description here of what you could enter. But actually, I think for overplotting and fine tuning, it's better to do that in PubFig.
So this can't do overlays?
I am, based on clicking the context help here, actually, I'm actually pretty sure this does not do overlays unless they're for different shots. So like, for example, if I add a different shot and do that, it's set up to overlay shots. I'm not sure about overlaying point names. Actually, I don't think it's set up to do that. And as you just saw, so this shows me one more thing I wanted to show, which is that you can just add as many shots as you want and keep overlaying your different shots, and they'll come in as these bolded labels. And then these are actually draggable. So if you don't even want that, let's say you're just doing something quick, you can scrunch your axis a little bit that way, even just move this off the axis so that it's not polluting things. And then you could, and this vertical line here is my marked time. I had entered on the advanced slide. So that's this marked time right here in seconds, but I could just remove that. Okay, there's my overplot of that. And again, resize this to your heart's content. And yeah, you can make pretty quick little things like this. Shira.
Last plot, add the word density on it, when none of the other times you've plotted density have said that.
So I think when I was doing plots of like, when I did the preset thing and it was filled with stuff, those annotations might have been like all scrunched up. I'm not actually sure. That's a good question. I don't know. I mean, here, I'll add, like, I think if I add another one, like, let's see, is that a recurring thing? It might only do it for the first. Yeah, now it changed. It did comma density.
No.
And it added ECE core. Yeah. I don't know. Anyway, again, I didn't even write this module at all, but I know enough about it to do the tutorial, but you always discover nice little Easter eggs, I guess. Yeah, go ahead.
Can this scope plot some variable versus psi or r?
Okay, yes. So now I'm going to get to the presets. So I'm going to go back to just a single discharge. So I showed, for example, on this tab, you can load, like here are different, I didn't get through all of these, sorry. There are different things. So for example, if people have predefined like magnetic probes, and then I go back and hit refresh. Oh wait, I forgot to hit load. It's okay. Restore magnetic probes group. And then there are all these probes pre-filled for me, and I can hit plot and get this massive plot of all these probes, for example. Okay, I wanted to show one more thing, sorry, which is that you can save, like once you've come up with a list of different signals you like. So let's remove all of that. If I just wanted, for example, beta toroidal and beta n over 4 Li, I can go in here and do that. And then I can save this, and then I could restore it later if I wanted to just save that. Sorry, I just wanted to mention that before moving on. So on the presets, so you asked specifically about plotting things versus like profiles. So there are all these presets here. There's NBI ECH sources, there's power flow, confinement, equilibrium, and then there's profiles. So if I click plot profiles, it's running its own code that basically grabs all the zip fits, and it will plot them for you as profiles like this. Okay, as a pause, there are different kinds of like plotting utilities that are built into OMFIT. What we're looking at right now, this is called a view 2D. So this is a method that exists just in the OMFIT framework. You can call anywhere from your own module, from anything, if you have a two-dimensional type data. And this has some things built in. So for example, as I click around in here, you can see it's showing me different like slices in row and in time. You can also drag to do like a window, and then it'll average and give you error bars like on the side. Sorry if like this is giving you a headache. It's like the profile, but transposed. And then you can also click these buttons up here. So like if you wanted to take the derivative with respect to row, it'll just do that for you, and you can look at it. And again, this functionality, it's still, you can drag windows, it'll give you error, and it'll give you, profiles with error bars on it. So this is a view 2D. If you're never really sure exactly different things you can do with this, you can open the help window with Control H, and you can type view 2D and look at the source code, and it explains an example of how to use this right there. But I wanted to say that, so yes, you can look at profiles, and yes, you can manipulate 2D things with this, and there's a framework thing called view 2D that you can use elsewhere. Okay, a couple more questions, go ahead.
The profiles that are plotted, are they fitted with quick fit or how?
Yeah, these are zip fits. So I'm not the authority on exactly what zip fit is, but it's an automatic profile fitting tool that I believe that basically there's different versions of it, but I think it's basically spline fits, or it can be M10H profiles. I think it depends on the settings for zip fit.
There are plenty of opportunities to do other types of fitting as well. And we'll go over those in future sessions.
Yeah, these aren't the only profiles you can make in OMFIT or for a given discharge, but this is just what's readily available on MDS Plus. That's why it's right here. And I should say that we're inside a figure notebook. So at the top, there are these different tabs, and it fetched all the zip fits. So the E temp fit is the TE fit, I temp fit from charge exchange, and rotation, and the impurity and all that. So they're all at the top. Again, figure notebook is another framework level OMFIT entity that you could use in your own code. And if you're not sure how to use it, you can search for figure notebook, and there's the source code, and it explains, you call it, you tell it how many figures you want, different names. So sorry, I don't know why my help window is massive, but make it smaller. Okay, Wilkie, go ahead.
We have a question online.
Oh, question online.
Maybe.
Maybe so that we don't
Yeah.
go through like a worm. Oh, okay.
Hi, yeah, my question was if you have, if you've been using Review Plus beforehand and you have like a saved Review Plus file with like your saved signals, is there a way to import that into OMFIT? I know the file, like with it being like
Yeah.
IDL based, it might be difficult, but just curious.
Not that I'm aware of, but you can, yeah, because they're like .rev plus, like its own format for saving that. So I would
Yeah.
venture to say no, but you know, with 5 to 10 minutes, depending on how many signals you have in your
Yeah.
plus, you could make your own, you know, with all your point names down here, and you could make it, label it here, and then these actually get saved in the tree as a group. And so here's my custom group, and this is a JSON file that you could just load, like you could save this in your home directory, for example, and then load it into a different OMFIT project at another date, for example. But that's like, you know, getting ahead of ourselves a little bit. But yeah, you could technically make a really complicated one of these and save it. Or if you are someone who is, you know, like, you know, would be a useful group for everyone would be, you know, whatever, something different, like people have made these CR LBO groups. If you are the proprietor of a diagnostic or whatever, and there's a group that you think would be useful, you could make it, put it in a tree here, and then actually export it to GitHub, and everybody would have it in their scope modules.
Gotcha. Cool. Thanks.
On a related note, the .rev plus files are text files. If you want to open them and just pull out the names, I'm sure someone can do that programmatically.
Okay, yeah, so in principle, we could convert between them. I'm not gonna claim right now there's a way to do that, but yeah, go ahead.
Are there any advanced features for working with very large data sets like downsampling?
Yeah, it under the hood in Scope, it's using OMFIT MDS value that we'll talk about. Yeah, there's a resample time here, but it doesn't work for PT data. That's an MDS thing. So it depends on what you're doing, but there are ways to decrease your, you know, I mean, it uses things like, pretty sure everything is lazy loaded or cached, or like, I mean, it's not just loading every single array into memory at once, I think, except when you're making the plot. But like during the fetching, I'm pretty sure it's caching the like calls, and then it only does it when it actually is going to render it onto the plot for you.
I thought the PT data came through the MBS server as a server-side macro using the PT data function. So couldn't you just have the server resample it for you before transmitting the data?
Well, now we are leaving the realm of the scope tutorial. I will say that I have recently, like 2 days ago, tried to resample PT data using OMFIT MDS value, and it gives an error saying you cannot resample PT data. So
Not with that attitude.
yeah, we have some work to do. So, you know, in principle, what you're saying was my understanding also, but I don't know. You know, different things.
Well, now I'm mad.
Okay, well, get on it. You can fix it. Anyway, so these presets, one that I often look at is the NBI ECH sources. This is useful. Okay, there's no ECH for this shot, so that's fine, but you'll get a grid like this with all the gyrotrons. I'll just tell you. This one's for NBI, so you have the left, right sources of each neutral beam and then the sum down here. So this is useful for dissecting exactly, okay, there's a beam blip at what time, which exact, you know, source was that. So, and again, things are a little bit bold and scrunched just because of I picked that different plot style, like this, all these axes would be a little bit more legible. And then, whoops, sorry. And then this one is really crazy. So I'll show it. This is actually a view 3D. So it's the same as view 2D, but if you scroll, you move through time. So we're actually looking at, this is, I believe it's like, yeah, it's normalized colloidal flux. And then if you start scrolling, you can see the time is changing. So like we're watching the evolution of the, you know, I mean, nothing's changing except I guess until we get to the end of the shot basically, but yeah, so this is kind of interesting. And again, you can do things like drag windows on here and it'll do the averages and stuff for you. So that's kind of nifty. And again, if you want to read more about that, open the help window, you can type view 3D, and then you can read about what that method can do. Okay, I think that's about it for that. I just want to quickly, oops, sorry, close it. I just want to quickly show PubFig. So once you, let's say for your shot, you know that, okay, I really want to look at density and temperature, what have you, then you can switch and you're writing your, manuscript. Actually, I've preloaded ones in here. So I have the shot, and then I want to plot IP and density, but I've put, you can read this help context for how to do this. It says for different plots, you put them as elements in the list, but if you want them on the same plot, you put a comma. So what I have here is IP and density, and then on a new plot, I'm gonna have PI and J, and then I have this CER auto TI from T1 and EC25. And then this will make plots that are like a little bit more, quote unquote, pretty looking for your publications. So you can make plots like this, and then these are draggable. So you could just move them. And I know this is bad form to have them the same color. You can edit the colors, change the boldness, all that you want. And then these, when they get over on that, you can just go like that. It gives you automatically the ABC things, and it puts your shot number up there. But I'll show you real quick. So all of these, like I get a different tab for each of these. So this is for really like fine tuning your plot. So, don't make one of these for like overview of a whole shot, because you'll have a bunch of tabs. But for just something like this, you can see I can scale different point names down, and then you could change their color. So like, I noted that IP and density were the same color on that last plot, so I didn't like that. And then also the labels here accept latex. So if you wanted to do something like that, so that it actually shows up as PINJ, you can do that. Give it a second, because I asked for it to smooth out PINJ for me. So yeah, so see, now it made it look like that. You can change the labels whatever you want. So for this EC25, you could do, T sub E and what have you. Okay, that's about all I really need to say for PubFig. You can explore, I think, how to, all these different options. Like here's the PI&J. So I had Gaussian window smoothing of 300 milliseconds. So I'm giving this really sort of just like, broad look at PI&J. And there's, really so many different combinations of settings you can do. And again, number of columns, rows, all the annotations. I mean, there's a lot of settings. Yeah, go ahead.
We also plot magnetic equilibriums.
Yes, but not in as part of PubFig. So for that, I'll show later how easy it is to do that. You just need basically the GEQ DSK object in your tree, and it already has a method called plot, and you just hit enter on it and it'll plot it. But I'll get to that later. Okay.
Is there a way to export the script that makes the figure?
Export the script that makes the figure.
Oh,
Oh,
yeah, you're making a set of instructions.
yes.
Jump that.
I would say so. They're all these scripts.
It's a Python. It's an OMFIT Python task, which means that it is part of the. It's utilizing the OMFIT Python-like language, but the function is passed through default bars. And can you open up just?
Yeah. Well, so I was going to show this. This is a really good opportunity to say, if you ever want to look at this script, you're like, wow, that was amazing. How did it make this plot? What is going on? What you do is you right click on a button. Again, I'm on a trackpad, so I'm like trying to. Okay, so here it's saying this plot button points to OMFIT Scope Intro Plots Plot PubFig. Okay, so we just have to go to the tree now, and I'm going to use my arrow keys to navigate, so you won't see me clicking the little chevrons, but and then it was in Scope Intro Plots and then Plot PubFig. Now I'm just going to hit the space bar, and it's going to open that script for me. And this is so when you asked, can you export the script? I would say, don't do that, because the script is so like, it's like a Swiss Army knife. So
that's not what I mean. Can you save your settings and restore them and edit?
Oh, that would be a good, I see what you're saying now. Like all of this, like these like keyword args that are passed to like Matplotlib, that's what you want saved. In principle, the settings, right, is you could get them from that, but I would say no, yeah, basically no. The short answer is that I'm aware of, I don't think there's a way to package up all of your, like all of these fine tuning, like these labels and all of that into like a JSON and just say like, that's it. But you know that, and others may know that all of that is theoretically stored somewhere in this settings text file, which though passing those around is tricky sometimes, but in principle, you could reload the whole module from that settings and it would come in with all the, fine tuning you've done. But as far as I'm aware, there's not a way to get that, but
That'd be a nice little feature to have
Yeah.
an export that would export your settings into a lift plot.
okay.
I don't think it currently exists.
So I'm gonna switch gears now because one goal I have for this
You
is
have
to
a
talk.
question?
Oh, one more question.
Question online.
Okay, go ahead.
Sorry.
Yeah, a question also regarding export. If one has a figure that will be published, one needs also to have the option to export exactly the data points that are shown in the figure. This is requirement not only for personal archiving, but also this is according to new data policies, we have to not only provide images or figures, but also the data shown in the figures. Is there an easy option to just export exactly the traces, the data points shown in these figures?
Yes. So actually there is, when you hit save here, you can see that it actually says save figure plus data. And when you click on this and then you put the location, it saves a PDF and it saves an HDF5 file that has all the data in it. So yes, sometimes you'll get an error actually that says unable to save something or other to the HDF5, but actually most of the time it did and does save the HDF5 file. So, but you'll often see that error when you're saving like a really complicated figure that might have like a color map on it, or like it'll have like some data that's embedded in the transparency of the figure or something like that. I mean, if you have something really complicated like that, it won't save it properly, but for something like this, it should work. I mean, I could save it and I don't want to waste time, but I could save it and go look and there'll be an HDF5 file that has the actual data points themselves in the file. I have, yeah.
Has anyone cleaned up the format recently?
I'm not, I don't know, but it does save the HDF5
I'm
files.
fighting fires all the time. That's not one of them.
It saves like everything and it's spammy.
It is spam, yes, it's
So
a mess, but
you asked for, it just basically dumps everything in the
It
HDF5.
saves it like a dumbass computer, like every detail of the image you can possibly save, it's dumped in there, and however, it's not.
I mean,
If I tried to
it doesn't package up a NumPy array for you and say, here you
If
go.
I tried to reconstitute the figure from that HDF5, I wouldn't do that.
Well, that's the nice thing about always publishing vectorized figures, in my opinion, is like all the data points are in it. You just pull it out. But anyway, okay, I'm going to switch gears because I actually want to spend time talking about the database creator workflow. So this is definitely the most powerful, I think, aspect of the scope module and maybe the most underutilized. So I wanted to take a fair amount of time to talk about this. So this example I'm going to show is actually from the scope tutorial that's on the OMFIT website. But I have another example I'll show with some more advanced stuff. So I switched the workflow to database creator. And the GUI completely changed. Okay, so now it's like we're in a different module, and it basically is like its own separate module within scope. And in here, there's different options, but if you just type, you don't have to worry about typing in runs. You can put in, for example, like D3D type run, like strings. That's like you get a whole list of shots from that, run day. But you can also just put in a basic, just a list with a shot in it. Now we have a similar sort of list editor here where we can pick different signals. So there's a few signals here that are related to confinement and also rotations. There's torque and one of the rotation channels from CR. Again, here they are as a list, but now I have additional options. So there's Elm filtering. I won't enable it, but it says, please see the help. And if you read this, basically says that it could take a while if you have lots of shots and, but I'm just skipping it. And then here you can select individual signals from this list, and you can get into the details of where exactly it's going to get them from. So these are all things that are just readily available, basically just from OMFIT MDS value. So you can leave this as MDS plus, and you can make your own labels for them. And then you can globally sort of truncate time spans for these shots here. And then you can fetch all of this data. Again, we're just doing one shot for now. And then, so I'll click that. And then we'll plot what exactly we fetched. So by default, it's everything. So when I plot it for this one shot, I get a figure notebook with one shot in it. And I have this kind of mess. Some of it's pretty noisy, like the torque data and the NBI is kind of all over the place. But you can see this is the data we got for this shot. Okay, big whoop. So but actually the next steps are what we care about. So now we can slice this data down to all be on one time basis. So here I'm specifying a user-defined time basis from the global times that I truncated. And then I'm saying I want data every 20 milliseconds, and I want to smooth everything by 50 milliseconds with a Gaussian window. So when I hit that, it doesn't actually do the smoothing, but it will just apply that to all my signals. But if there's a signal I want to smooth differently, you can go to this signal-specific smoothing. And let's say you want the torque, smoothed over 100 milliseconds, for example, you can do that here. Then when you click slice data, it's going to take all of that and apply those operations. And now when I plot it, you'll see that I have this green annotation says these are the database slices. So a lot of that noise has gone away because I've applied some smoothing, and they're all now on this time basis. So these are just operations that are common to do, and this makes it easy for you to do to a lot of different signals at once. Okay, but we're just getting started. Now, the fun, I'm gonna jump all the way to plot. This is where you can make some really interesting plots and look at your data maybe in ways that would help you as you're analyzing, a given shot. So in this case, I can plot as the x-axis torque. I can color all the points by the MHD N2 RMS value. And then I can put the y-axis as the energy confinement time or the rotation. So when you do this, you can look at all the data from that shot sort of in this sort of database type view. So in this case, we can see there's clearly a correlation between the torque and the energy confinement time. And based on the color, when we are at lower torque and lower energy confinement time, the N2 RMS is what's, I don't want to assign causality here, but okay, you know what I'm trying to say. Like the N2 RMS picks up at lower torque values. And then here's the rotation. You can see clearly between torque and rotation, there's a correlation that should not be surprising. And then at low rotation values, this N2 RMS picks up. So now you can start to look at, your data like this, which could help you, extract meaning. Yeah, go ahead.
Can all of this be done with some data that we upload to OMFIT?
Good question. Okay, yes, but with more work. I'll get to that a little bit later, like how to maybe supplement this data set with your own data that maybe you got from somewhere else. Like if you had stuff every 50 milliseconds, you could add that in. There's other plots you can make, there's a lot of stuff built into this. So these scatter matrices. So you could do all these variables like NBI versus energy confinement time. And then here's kernel density estimates of each of the variables. And here's 2D histograms of each one. You can get really fancy with this. You can also make these 3-dimensional plots if you are inclined to do so. That one actually, okay, sorry. So here now you can look at NBI power and energy confinement time, and you can move this around and maybe, try and see something cool. But again, that's kind of maybe a little bit extra to do that. Okay, then finally, you can do fitting. So this is database style fitting. So the options are pretty much polynomial fits, or you can do these log linear fits. So what that means in this context is kind of like the H mode, Eater confinement scaling. That's variable to some exponent, variable to some exponent, variable to some. That's the kind of fitting you can do. So for example, if I wanted to do one of those on the rotation and my regressors were the NBI and that N2 power, when I click fit and plot, I get something like this, and I get my regressor things here, so that it's the rotation is this coefficient times the torque raised to the 0.8 power times the MHD power raised to the minus 0.1. So it's not, strongly. And you can look at histograms. Here's just the torque value relative to that scaling that you just fit. And then, here's the MHD power relative to the scaling. So it's you could look at how it's basically the residuals. Anyway, so you can do fancy database things like this. You can also just fit a line. So if you just go back to polynomial and you just do torque versus rotation with a 1 degree polynomial, you know, okay, it's, you know, you can extract the rotation as a function of torque for this discharge. Okay, and then this, to your point about, so I wanted to point out that this thing, if you go to scope database, here's your slice data. So it's just right there. And this is a data set that has all of these variables in it. So like if I just hit enter on one of these, it'll just plot it. But the, you know, all that's there. So if you wanted to supplement it, you could have another, you know, you could add your data to this X-array data set thing that sits right here. Okay, for something more advanced, this one I definitely pre-cooked. So this has a lot of shots in it and it has a lot of variables. And I wanted to point out that some of the variables, they don't just have to be from MDS plus. So for example, like A over LTE, right? So like the inverse gradient scale length, you can select from source. It doesn't have to be MDS plus, you can pick ZipFit. And then there are these different options. So ZipFit 01, and I'm talking about the E temp fit. And then you can just check this box for, I want the A over LX, and then you can specify the row location. So like, that's pretty interesting. You can just, you know, extract local inverse gradient scale lengths if you want in this database thing from many shots. Also, I have like QE in here. So I have like the electron heat flux. So here you can grab something from a transfer run, or you can grab it from the auto 1-2 tree, for example, and you can put in the variable you want, like the 1-2 variable. So in this case, it's this E flux E. And then you can, again, pick, I want, you know, the variable at a given row. So if you want like local heat flux, and then there are other options, but it doesn't make sense to calculate like A over L for QE, but I mean, you could if you want to. And then there are just, again, like I said, there's also like new effective. This actually comes from a library of functions that are built into Scope, that it has other things like you can go look in there for what the options are right here. So all of these like PLH Martin scaling, like it has a function that it knows how to just compute that scaling, for example. But there are all these other ones in here. Like, and to know what these are, they come from this lib, and I believe they come from OMFIT lib database. And yeah, so like they're all in here as, you know, new star PED. So you can read what exactly it's calculating, so that you know, have an idea if you're not sure. Okay, so now with this huge database, I wanted to show also derived quantities. So I skipped over this in the last one because we were just doing basically rotation versus torque. But here, let's say I actually want to define A to E as the ratio of A over L TE and A over L NE. So I can go to ZipFit, get my A over L TE, A over L NE, and then as a derived quantity, I can write in here A to E equals that and hit add expression to list. And now it'll calculate for me based on that, whatever expression I write, it'll add it to my database. And similarly, like TE over TI. So I just put, I want the ECE core over that, you know, TI core from CER. Now I have a derived quantity that's T over TI. And I did a few here, like I also did density peaking. So I asked for the density from ZipFit, like at row of 0.2, and then, you know, versus the line averaged or whatever. And you can take that ratio and call that your density peaking factor, for example. You can do whatever, you know, there's infinite derived quantities you can pick. Then I also want to show selecting. So I skipped over this last time, but you can say, for example, this shot is just not a good shot. So you can just say shot equals that and add that to this reject list, and it'll remove it from your database. It'll mask it out. Or you could say, I was really interested in higher density stuff. So you can just add density less than 2.5 e to the 13, and it'll remove that from your database as well. Now you can, you know, here I have like new effective colored by TE versus TI versus these QE, you know, thing. And you can do also, you know, you can make more complicated plots that are like the collisionality, you know, colored by T over TI versus the heat flux. So like my lower collisionality, higher TE over TI, you know, data is in this cloud up here, and my higher collisionality or whatever, you know, I may have just said it opposite, but those are down here with lower electron heat flux and also lower T over TI. You know, you can start to get into like more advanced sort of slices of data in this way. And again, you can also grab things from transprons, but I didn't have transprons for like all dozen of these shots. So, but you could also do that. And then also on the fit, I recently added piecewise linear. So like if you wanted to do, different kinds of fits. So there's also like this one, for example, I'm totally like making this up, but if you were looking for critical gradient type behavior and you want to do like A over LT versus a flux, you could put that and, you could get a plot like this. Here, doesn't really look like much. It's kind of a mess, but that's up to the physicists, to decide what's real. Okay. Any questions on this part before I go into the last couple of things?
Where does it say the equations that you used for the derived? Is there a derived branch?
It adds them, yeah, it adds them into your slice. So like in here now, there's this T over Ti thing.
But the
equations themselves, I think, are just in the settings. I would guess.
Okay.
I'm not going to go looking for them, but they're probably in here somewhere. I mean, I think I could right click this and it would tell me, yeah. So the derived list is in scope, inputs, DB, derived list.
Okay.
So inputs, DB, derived list. So here are my different.
Oh, nice. Well done. So you weren't going to go looking for them, and then he did it.
I did it. Well, I thought
he's an overachiever.
I'll show right clicking shows where stuff is usually. Yeah, Philip.
Yeah, so I think you mentioned that already, but if I want to add a function that is not in the list, for example, I don't know, adiabaticity or whatever quantity I want to calculate, where can I put it? Like, can I write my own function and put it in the library so it can?
You can, yeah. If you wanted to actually develop, like add something new to the scope, I mean, just in your own project, or if you were feeling generous, you could export it back up to GitHub for everybody to use. You can go to this library and then you can add your own functions to this database thing. And then you might have to do a little bit more overhead to like add it to the drop-down menu. But actually in general, you could do it separately. So like over here in a script, you could write something that calculates whatever, and as long as you add it to the same time coordinates as this slice object right here. So this Xarray data set has all these data variables and has this time coordinate. Xarray has methods that are like combined by chords or merge. So you could make your own little Xarray thing in this command box and then just merge it. But then, user beware, you might break some of the plots. I want to show like an example of, you're not confined to just what's in scope. So it's not like all that data that you work so hard trimming and resampling is just like stuck in that module. So here I wrote a script I just called it scope db bonus. So here you can do things like this. Just make yourself an OMFIT Python task, a script in the tree that takes as inputs the slice and the mask, like from your scope module. So that's what they take as inputs. And then you can just pick a X variable, a Y variable. And here I'm showing like with just this many lines, so not many, I don't know, 12 lines or whatever, I can make like a custom scatter plot. So in this case, I want to color the data in the scatter plot by the kind of auxiliary power. And then as another thing, maybe you want to do some advanced analysis, like more advanced analysis. So in this case, I'm importing from scikit-learn the Gaussian mixture model, and I'm going to like fit like, different clustering algorithms like to those different collisionality regimes in that plot I made before. So like, so that script took data that I pre-processed in scope, and now I'm making something fancier with it. So this is my plot of new effective versus A over L, NE, or whatever I had, QE. Now I've like, the colors aren't showing up very well, but now I'm plotting this like with the green points are ECH only, and then these points are actually mixture, ECH NBI, and then these are NBI only. And then the scikit-learn thing added those contours where it's trying to fit like a cluster to say like, oh, whatever, that's the maximum likelihood, clustering of these different sets of data. For example, this is just an example. I'm making all this up, it's whatever. But you could take that data and do something more advanced with it. That's the point. Okay, that only took 1 minute. So now I'm going to show, great, we did all this in the GUI, but like, I just want my data as an array, or like, I just want to make one plot of IP, or like, where is all this data? So now this is an example. I have 3 examples here of just direct calling OMFIT MDS value. So in this first example, this is probably the simplest thing you can do. So I just put OMFIT MDS value, D3D, the tree name none means PT data. You can also put PT data, I think, in there, but it's the same. Then I put a shot number, And then for TDI, you put IP, for example. So when I run this, it just plots IP for that shot. So there you go. And of course, you have access to like the data's like this thing, data equals temp data. Like, you know, that's, you know, you have that as an array now. Like it's a long array, but you can manipulate it or do whatever you want with it. You know, for example, I'll show, you could put it in the tree so that you could do whatever with it. So now I have it in here. And if you click P on items in the tree, it prints them. And if you click enter, it usually will plot them if they're an array. So, okay. You can also right click on this and you could actually deploy it as like text file. Usually there are better options, but I think because it's an ND array, if it was something else, you could save it as like a netcdf file or something, but just saying you could export it, whatever you want to do. Okay, now to the point about zip fits, earlier we brought up like how do you get profile data? So that's this example right here. It's all recorded, so like you could pause the video, I guess, if you wanted to relook at this, but this example I'm fetching from the electrons tree of MDS plus, and then you get the profile fits, zip fit, edens fit, and then again, shot number, D3D, and then I'm just gonna plot all of them on top of each other, which is a mess, but there it is. You could, you know, you could tell it to plot only for certain ranges of times or whatever, but I'm just showing that, yep, there's all the, you know, zip fit density profile fits. And then finally, fetching G files somebody asked about. So this, we're gonna go into more detail on this. Definitely next, I think the next OMFIT tutorial is EFIT time. So there'll be a lot more on this, but this is actually a nice function that you can put in a shot, a time, and then actually it's just from MDS plus with underscores and tell it D3D, the shot number. You tell it times as a list because actually it's set up to get you like lists, like whole shots worth of G files. But here I'm just putting one time. And then I tell it snap files EFIT01, and I don't need the A file. And then I'm going to put it in the tree. So I'll run this again, but it had already put it in the tree. And now right here, I have this object, and then you can hit enter on it to plot it. So there it is. Okay. All right, I hit everything, and now I'll take more general questions in the last 5 to 10 minutes. So anything about what we talked about for the past hour. Yeah, go ahead.
If we want only the magnetic equilibrium and not all those profiles, for example, how can we define, like modify the plots?
Good question. So actually you can copy this. Here, I'll do it over here. Dot plot only 2D equals true. Was gambling. It might be only 2D like that. Hang on. This is why we have the help. Oh, it's only 2D like that. That's what I tried. Oh, is it?
Alt escape closes them all.
There. Sorry.
If you go to another window, you can also just launch EFIT viewer.
Oh yeah, sure.
Yeah, that's what I would use for.
So that, there's also in the geoglyph itself, if you click the drop down menu, of course, you can see the flux surfaces and everything.
And here, yeah, I can pick one. I mean, okay, I don't, this isn't we could do a whole other tutorial on each.
Yeah, we're gonna get this some next week, so.
Okay, fine.
Quinn, can you just open up the tree of the geoglyph?
Yeah, I will, yeah.
It's nice to see that.
Okay.
Don't worry, we can kind of all back to.
Oh, no, it's fine. Okay, then there's that. Great, you get all the slices. Yeah. David could talk about this more, but
It's slow now. It used to be fast.
it was generally pretty slow for me. No offense, but okay. Then yeah, if you expand the tree of a G file, you can actually see, like, mostly I jump right to aux quantities. That's where like magnetic field and things like that are. So like here's row RZ, and if you hit enter on a 2D quantity like that, it'll plot it, but it's plotting it versus like array element. So like it's RC, but like the pleural field coils are up there and stuff. So it makes it look weird, but they're like the core is, you know, right there.
I had one comment. The question earlier, we were talking about how to generate your own custom derived.
Yeah.
A recommendation I have is if you go to the scripts, there's a DB derived, and that's how it's generated for the typical stuff. You can just use it as a template for doing your custom derivations and just plug it right into that script. So as an example.
Yeah. Look, he's online.
Yeah, only question?
Yeah, please.
Me? Can I ask a question?
Yes, go ahead.
Sorry. Maybe it's a bit out of the scope, but can you also plot the overlay of diagnostics with this OMFIT viewer?
Yes, you can. Now I regret that I closed it.
Sorry.
But yes, you can.
It was fast for like 2 weeks after it was implemented, and then it got bogged down.
Sure. I'm teasing. Yeah, there was a time. Anyway, yes, you can go to, oh, they're all right here. Sorry. I know, but I clicked the tab. Give me 1 sec. Okay, yeah,
Okay.
Thompson. And interferometer. All of it. Bolometers.
This is really nice for like if you have one.
Yeah. Yeah. Okay. Other questions?
We have some group plot functions, like I want to compare 120 channels versus another 120 channels, and then each channel I want to put one subplot, and I want to double check maybe 10 page of each page has 12 channels compared to each other. Is there some function like that?
Yeah, for that, I mean, I would write my own script to do that. So yeah, like.
Yeah, right now what we're trying to do is kind of illustrate some basics so that you can get in and quickly start looking at data. But obviously you're going to need to get to the next level, which is when you start customizing to look at it the way you specifically want to look at it. So, you know, there's definitely 2 levels, and right now that we're kind of focusing more on the automated, you know, it's predefined. Everybody, we just use this tool for
Yeah.
checks.
But how I would do that is I would probably use this example, this PT data example, and you can loop, like put this thing in a for loop. So just make a big list of all your signals, loop over them, and just go crazy plotting or saving things outside the loop or whatever you need to do. Downsampling in the loop, but I don't think there's not a predefined thing for like hundreds of scatter plots. And I mean, you know, you can like, yeah, but you can make it yourself. Yeah.
Or if it's generalizable, you can also share it. I mean, if it's a generalized thing, it really should be in there. That's part of the great thing about this community is that we share things, and so it can become part of our features.
We'd like to compare the calculated magnetic signals versus our measured magnetic signals for each plasma shot, right? We have 120 or even 250 magnetic sensors. If that function, that's easier to compare each the calculated and the measurements, right?
Right.
Yeah.
Makes sense.
So you could write a plot that fits in here, for example, like scope and then plots and then inside D3D or something. You could add like a plot underscore whatever calculated versus measured magnetic signals. Then you could add it in the GUI to presets, and right here it would be like plot, whatever you want to call it, and then export to GitHub, and everybody could benefit from that. Your 120 scatter plots or whatever you wanted to do. I'm just teasing, but yeah, Jeff.
Yeah, suppose you want to plot something that's not in one of the presets, but you don't necessarily know what the point name is for it. Is there a way to browse that, or is that on you to figure out another way?
Okay, there is a way, but you use the qualifier convenient. So I'm not gonna. So there's open signal search, and you can type things in here. Like I can type density and hit search, and then maybe that was a bad example. We'll see. Then, in fact, that's a good example to show where this goes kind of maybe wrong, which is that you'll get all of this. So you said convenient, and maybe this is convenient. I don't know, but maybe you just wanted to know line average density, and this comes out, which doesn't tell you. But actually, it's right here. You know what I mean? Like you could find it in the list.
Right, but it's only searching point names. It's not searching any like metadata annotation of what, because like point names could be very convoluted.
Oh, so for metadata, like about a shot, there's the OMFIT RDB function, which I did not talk about, but that can search the relational database and you can put SQL type queries in there. I don't know if that like, so you could search like all the shot logs for somebody mentioning, okay, you know, whatever, we got really low collisionality, but like often those might be riddled with typos or people don't fill them in or so like, you know, I don't know.
My question is,
For the diagnostics, like metadata diagnostics in open signal search, there is a search description
okay,
box.
description, yeah.
But that again relies on people that wrote the point name to have a good description. So you may or may not find what you're actually looking for.
I guess, is that just for the MDS plus tree items or also the PT data stuff?
No, this was PT data. So like all this stuff that came back, some of this was PT data, I'm pretty sure.
Yeah.
Definitely. Yeah, like when I've searched for different, like I think I've searched at one point channels of a bolometer or something, and you'll get, I mean, whatever, you'll get a bunch, everything, like an uncalibrated, whatever this thing, like description. But yeah, like here's like, I don't even know some of these, what these are, but there's different things. Yeah.
Thanks very much, Quinn.
Great.
So we'll see you back 2 weeks from now. We'll be talking about EFITs.
Right, stopping the recording.